number 4. Test number 4 will cover polymers, lipids, and carbohydrates. What I'd like to do now, today, like I've done before, part of the day, I'll be doing the review. Then I just want to cover the last part. And then tomorrow, we'll do the carbohydrate problem set, which will be on test 4 for Thursday. But I finished that material last week, so you have plenty of time to look at it over the weekend. And next week, I'll start my year-end review, which will help students say it really helps. All right, as always, if I've talked about something twice in lecture or more, it's fair game on a test. And if I forget about it in review, I apologize. I usually don't, but let's get going. Starting out with polymers. What's a polymer? By the way, I should warn you, after May 1st, my spelling goes downhill. I was always the first one down the spelling bee. Right, polymer, macromolecule, which means a big molecule, made up of repeating units called monomers. When we talk about polymers, there's two types, or ways of classification, one by chemistry, one by physical properties. First one, for chemical properties, type of polymer, addition polymer. And addition polymer only has one type of monomer. It repeats over and over again. Examples. Rubber, like in your rubber tires, are addition. Saran wrap, polyethylene. Is an example of an item that's an addition polymer. Another type of chemistry is a condensation polymer. And there, you have a polymer made up of two or more different types of monomers. Here it's only one monomer. Addition, condensation, you bring two or more different types of monomers together. Examples would be my plastic water bottle, polyester, and that's a condensation polymer. You have something made of nylon, like a nylon raincoat jacket or nylon jacket. That's also would be an example. And I guess the other things made out of nylon, like a nylon parachute, for those of you who do parachuting. By the way, I don't have the courage to ever jump out of a plane with some nylon strap to my back. No, thank you.
My grandmother did it for her 60th birthday and said it was the best thing in the world.
I'll let her take my ride too. All right. The other type of method for classifying polymers is by physical properties or key physical property. And the first one of those is thermoplastic. Thermoplastic, what does that mean? I'm glad I typed most of my slides out. Let me decipher that. A polymer once made and shaped, in other words, made into like a bottle, can be reheated and reshaped. That's a thermoplastic. Example would be plastic bottles, recyclable, saran wrap. By the way, there's no correlation between physical properties and the chemistry. They can be either one on either way. The other type of physical property, or under physical key physical property, is thermoset. And that's a polymer and that's a polymer, once made, can't be reheated and reshaped. Once you make it into a certain shape, you cannot reheat it, you cannot reshape it. And an example of that would be rubber tires. Another one would be urethane foam, which you're sitting on right now. That's everything I covered in polymers you need to know. Next, I talked about lipids. These are molecules Lipids are molecules from plants and animals that are not soluble in water, but are soluble in should be non-polar. Non-polar solvents. I saw a couple of you looking at me, what is he talking about? Anyways, when we talk about lipids, two types of saponifiable lipids, non-saponifiable lipids. Saponifiable lipids are lipids that saponifiable lipids are lipids that react with base and water to yield a carboxylate anion. Now, to your general functional groups, I can use shorthand like I normally would to other traits. React to yield carboxylate anions of fatty acids. Non-saponifiable lipids are lipids that do not react with base and water. On my notes, I think I said alkaline conditions, either way. When we talk about saponifiable lipids, what we're really talking about are fats and oils. When we talk about non-saponifiable lipids, what we're really talking about are steroids, your hormones. Saponifiable lipids, also known as fats and oils, are triglycerides, which mean they have the following structure. And as you notice, each right here is an ester, 3 esters. What's the functional group in a fat and an oil? Ester.
What is the word after lipids that?
And right here,
No, in the middle.
react.
Okay.
There you go. Translated to handwriting. Aren't you glad I typed my slides? So am I. All right. You should know what's the difference between a fat and an oil. A fat is a solid or semi-solid at room temperature. For those who want to know, room temperature is 25 degrees C, but this works for me. An oil is a liquid at room temperature. Standard fat or oil as triglyceride, reactions you learned for test number 3. If I take this and react it with acid and water, what is that? Acid hydrolysis of an ester. And remember, this is how your stomach breaks down your fats and oils and to give you nourishment from that. Each ester gives me an alcohol. 3 alcohols are connected together in glycerin. And I get 3 carboxylic acids. And as you see with the acid hydrolysis of an ester, that's what you get. I take a triglyceride, react it with base and water. This is saponification of an ester. Which you also learned for test number 3, to get back the alcohol you would have used to make that ester, and the carboxylate anion of the carboxylic acid you would have used to make that ester. 3 esters, I get my 3 alcohols, which is glycerin. Speaking about glycerin, which I've seen a couple of you use on your extra credit project, remember, by the time I walk out the door of this building Thursday, if I don't have your extra credit project, no late projects are accepted. And that's what you get when you saponify a fat or oil, which is a triglyceride. There are different ways to make a reaction go quicker. One is use a catalyst, acid, base, but another way to make a reaction go quicker is increase the reaction temperature. And for hydrolysis, that means making it hotter. And what's hot water? Steam. And I showed you this reaction where if you take an ester react with steam, you'll get the same products as acid hydrolysis, but it's cheaper and safer. carboxylic acid and the alcohol you would have used to make that. And as I mentioned, so reaction company I work for did 2 to 3 million pounds a week, every week. And last I looked on the internet, they're still on the south side of Chicago cranking out fatty acids. And you get back glycerin plus the fatty acids. Unlike other instructors teaching organic here, you're the beneficiary, in my experience working in this industry. This one?
Yeah, sorry.
I'll slow down. I was a fat or whatever, you got it from the one that was here, same thing. And based on that, there are a couple names of fats you should know. Tallow is beef fat. Yellow grease, pig's fat. White grease, also pig's fat. And you should know these. And when you hydrolyze either acid or steam, the carboxylic acids you get from that reaction are called fatty acids, short for fatty carboxylic acids. I asked you to learn the structure of two of them. First one is stearic acid. Which is a saturated acid, which has saturated fatty acid. You should know is a saturated fatty acid, which is a fatty acid with only carbon-carbon single bonds. You should know that definition. And here we have oleic acid. You should know the structure. On the test, I wanted to put the structure and what's the common name, oleic acid. I put on the test, draw the structure for oleic acid. You should be able to draw it. And notice it's got a double bond, and it's that carbon C9. 1 plus 7 is 8, that makes that 9. This is an unsaturated. Unsaturated fatty acid. An unsaturated fatty acid is a fatty acid that contains at least one double bond. Mother Nature never, in anything she's ever made, has used a triple bond. That's something organic chemists came up with, not Mother Nature. And if you look at this, what's the difference between a saturated and unsaturated fatty acid? Double bond. One has it, the other doesn't. If I were to put yellow grease, white grease, or tallow, and react any one of those three with acid and water, what am I really asking you to know? Artificially, I define tallow, yellow grease, as the following structure. Where R sub S means this, R sub O means this. And therefore, if I react this with H plus and water, what I'm really showing you is acid hydrolysis of an ester, 3 esters, you would get 3 alcohols, glycerin. First ester would give me stearic acid, which if I do R sub S, you can write it out. You don't have to write out all the carbons. If I ask on a test, draw the structure of a molecule, then you do have to show the carbon. Second ester, my R group is R sub O, so I get oleic acid. And notice the third ester, I would get stearic acid. On a test, I ask you to give the organic product or products, not to balance it. Therefore, I'm done. But if you want to write this again, that's fine. If you want to put a 2 there, that's fine. You should also know if I have yellow grease, tallow, or white grease, react with either NaOH and water or steam. You should be able to do the products. All you have to do is go back and look at the earlier ones I just erased off the board, and you know steam would give you the same as this. Sodium hydroxide would give you this, plus these are carboxylate anions. And that's in the problem set which I went through yesterday. Time to rest your fingers.
say that if you only put like white grease, tallow, and yellow grease and not the structure, what would we have to write as the product? If you didn't put the structure, like if you didn't require us to like write the structure when you asked what's the reaction?
Oh, no, what I meant was, if in a reaction I give carbons here, you have to show carbons, but if I use shorthand like this, you can use the
Okay.
shorthand over there. But on a test, if I were to ask you, draw the structure of oleic acid, you can't put R sub O. I'm asking for, show me the carbons.
Okay.
As I mentioned, there are a few things I'd like you to leave my class knowing. One is, how does soap work? How to get your hands clean. And soap has nonpolar tail, polar head. How soap works, the most important part is like dissolves like. Things that are polar are soluble in polar things. Things that are nonpolar are not soluble in nonpolar things. Mix opposites together, they're not soluble. When you're cleaning up, whether your hands or other things, use water, which is polar. If you're trying to clean dirt or grease off something, like your hands, those are nonpolar, which is why you can't use this water alone. And if we look at a piece of dirt that was on my hand yesterday, you'll see that when I went to use soap and water and went like this, the soap molecule said, dirt, you're nonpolar. I know like dissolves like. My tail is nonpolar. I'm going to do this. And more than one molecule of soap does that and surrounds the whole dirt particle and forms what you should know is a micelle. Micelle now is totally surrounded by soap molecules with the polar head on the outside. Water looks at the micelle and says, you're polar, I'm polar, I know like dissolves like. Let's go down the drain together and your hands are clean. Next, I talked about non-saponifiable lipids, otherwise known as steroids or hormones. I asked you to learn how to do one thing. And that's draw the ring system or skeleton for a steroid. And that is a 6-membered ring, fused, connect to a 6-membered ring next to it. Right up here, not over here, here, another 6-membered ring, and right next door is a 5-membered ring. And all your steroids, in other words, your hormones, have this ring structure, and you should know how to draw it. I didn't put the structures you should go back and look at. You should be able to figure it out.
No, I'm talking about, is that supposed to be an O or a C where there's the double bond?
Those should be Cs. Or, I see, that should be an oxygen. Ace makes waste. Oh, one other thing, under fats and oils that you should know, how to describe when you eat a fat or an oil. With words and with a general reaction. That's acid hydrolysis of an ester, and a general reaction is this. Ester, acid, water, carboxylic acid, alcohol. Next, I got into really fattening area, dangerous for me, carbohydrates. And what's a carbohydrate? You should know. I can spell it. What's a carbohydrate? It's a polyhydroxyaldehyde or polyhydroxyketone or a molecule upon hydrolysis that becomes a, actually it should be over there, this becomes a polyhydroxyaldehyde or ketone. I stopped and went back and talked about chirality, handedness. And chiral is Greek for handedness. I talked about mirror images, which I won't be ever asking on a test. What's a superimposable, non-superimposable, but you should know that. object is an object that has a non-superimposable mirror image, meaning it has handedness. Achiral object is achiral. A means without chirality, without handedness. That's a object that has a superimposable mirror image. If you're trying to identify, and I'll go through this tomorrow when we go through the problem set, if you see the word left or right in the name of an object, immediately you know it's chiral because it has handedness. For those who came in late, since we have lab afterward, and those Thursday people have lab too, and go about an extra 20, 25 minutes after the end of the day's lecture. I have not done that all semester, but this way I won't have to rush tomorrow too. All right. Talk about chiral carbon atoms, and these are carbon atoms. Chiral carbons are carbon atoms with 4 different atoms or 4 different groups, or combination of 4 different atoms or groups. Antimirror is a molecule that has a non-superimposable mirror image. And as I went through class, I talked about draw the enantiomer or something. That's draw the mirror image. And we'll go through that tomorrow in the problem set. I talked about optical activity in D and L plus and minus. That won't be on the test. That won't be on the test either. Test number 2, we had a reaction of an aldehyde and ketone with an acid and alcohol to give you hemiacetal or hemiketal. For glucose, you do not have to know the structure of glucose on my test. For glucose, this hydroxyl group at C5 attached the carbonyl carbon I should mention, for those of you who have lab today, we'll start later. Today's lab, with me talking, you doing the lab, will take a total of less than 45 minutes to an hour. So even if I get out of here at 11:15, 11:20, you'll still get out of the lab by 12:30. All right, here again, because it's in the same molecule, you don't need an acetal since it's equilibrium, and you should know how to do this. Also with fructose. Again, hydroxyl group on C5, this alcohol. Now you have a ketone. This carbon here comes this one, and you should know this equilibrium. Again, this is fructose. You do not have to know the structure. If I take a hemiacetal or hemiketal in test 2, you learn you reacted 2 molecules of an alcohol to make an acetal or ketal, but in Mother Nature's chemistry, you have an unsymmetrical acetal by taking the hemiacetal reacting with a different alcohol. This carbon right here is this carbon right here. This hydroxyl group is this hydroxyl group. Therefore, if I have it written like this, same reaction, place the hydroxyl group with OR triple prime. and that's to change. And this allows you to make hemi or acetals or ketals and glucose, as I showed you, linked together by that acetal linkage is what holds many glucose molecules together to make starch. You take fructose and react it with glucose and make an acetal linkage. You make table sugar. And we'll cover this again tomorrow. And what that means is all your disaccharide, sucrose, and your starches are held together by either acetal or ketal linkages. And a reaction you should know, and how to describe it. With words in general reaction, when you eat a carbohydrate, what's the key functional group? An acetal or a ketal, really an acetal. And you react that with acid and water. You learn this reaction test number 2. You get back the aldehyde or ketone you would have used to make that acetal plus the alcohol. In our case, they're connected together. We call that glucose. Therefore, this is acid hydrolysis of an acetal, and you should know how to describe when you eat a carbohydrate with words, acid hydrolysis of an acetal for test 4, test 5, and you should know the general reaction. And what that means is take starch, chew it, swallow it, goes in your stomach, acid and water. You break the acetal linkages, and what do you get back? Glucose. You take sucrose, you add acid and water, what do you get? Well, you break it down to what you made it from, fructose and glucose. All right, does anybody have any serious difficulty if I go a few more minutes, cover an important thing I want to get done now, instead of rushing work, drive tomorrow and doing it? Just smile. Again, I appreciate your letting me do this.